everyone, welcome back. I'm back at my own base. So last time we did multiple factories. We have completed like the radio control unit factory, then we did heatsink factory, which led to us making, I think, cooling system factories and also supercomputers in between those. At the end of it, we made the supercomputer factory. So everything is done. The only thing that's left out is like the fused modular frame factory. So I just wanted to complete that before moving further. So before the next milestone unlocks, I want to complete this. So that's what I started building. And look at this blueprint. I did not think it would turn out this way. This turned out to be a lot more complicated, lot more complex and intricate than I have ever done in a blueprint designer, at least in 1.0. So yeah, this is looking really good. I was a bit hesitant, or I was not really thinking that I could complete this blueprint in like starting from raw resources all the way till the end. But I was able to do it. I'm really happy about that. There are lots of interesting parts or design aspects of this blueprint, which I'll go through. But most importantly, I think, so the first thing is, right, let's take a look at this recipe. So I could not unlock the next alternate recipe. It's probably, I need to unlock some other future milestones before I can get that. So I was fine with that. This recipe is not that bad either, so I was fine. So before I started making the blueprint, I like to make blueprints with good numbers, so that when I use this blueprint, I can easily put this if I want to use it in a future factory. And I was thinking about that. So one thing, so fused modular frames is a very, very late game stuff, and the thing that it can be used for in the future is like turbo motors, or most probably it's just space elevator parts. And this is probably used for very, very late game space elevator part. So you don't really need too much of it in terms of throughput. So if it's something like 1, it makes sense. Like if a future space elevator part needs like 2 fused modular frames per minute, I can just plop 2 of these down and I'll get it. But I started taking a look at this. So the numbers, 1 heavy modular frame is fine. I already have a factory blueprint, in fact, which makes exactly 1 heavy modular frame. There is 50 aluminum casing and 25 nitrogen gas. These 2 numbers are not that good, because the way that I am doing the blueprint, 60 aluminum casing is what I get from 1 blueprint, and 25 nitrogen gas is actually a very not so good number. It's not a multiple of 30 or something like that. So I cannot really perfectly balance it. I just have to put a lot, like 30 nitrogen in it, and just let that be. So I was taking a look at this, and I thought, maybe what if I make this like 1.2? It is still underclocked, but I'll get 60. This is 30 nitrogen gas, so these 2 numbers are perfect. 1.2 heavy modular frames and 1.2 fused modular frames is the output, which is fine. Just a little bit more than 1. So if I need like 3 fused modular frames, I can just plop 3 of these down. Yes, I'm making a bit more fused modular frames than required, but it's still fine. It's not that big of a deal. But I think I'll need a lot more than 3 fused modular frames per minute. So for the very late game space elevator parts, I'm not planning on building like hundreds of these per minute. I am only planning on building like 1 or 2 per minute. That's it for the very late game space elevator parts. And that should require around, I don't know, like 5 or 6 maybe. If it's 6, it'll be perfect, so that I can just plop 5 of these down, and that will make 6 fused modular frames per minute. No matter what, at the end of the day, I went ahead with this recipe. This underclocked recipe, so that the numbers are good, specifically for aluminum casing. Aluminum casing is the tricky one. Nitrogen gas, I am fine, even if it's a little bit less, little bit more. It's just a raw resource, right? So I can just bring it no matter what. But the aluminum casing one was the tricky one, because I really wanted this number to be good. And 60 seems good. 60 is perfect actually with the blueprint. So the next that was left with is heavy modular frame. By the way, you can just right click anything. So if you are looking at this recipe, you can underclock, overclock, all of that. Along with that, you'll get a couple more recipes here which uses this fused modular frames, which is used in. But here I haven't unlocked any new milestones, so I am not seeing it. And also, I can just right click this and go to open codex, and I can go to that recipe. So that now I know I need like 1.2. So I can just put 1.2 and see how many of the other stuff that I'll need. So I can compare all recipes like this. This is so nice. Some of these are incorporated in 1.0. I don't think some of this was there in early access. So this is really nice. Of course, this codex and all was there, but I think this used in part was not there in early access, which is really nice. This helps me quite a bit when I'm planning on deciding which recipe to use and all. So that's nice. So I need 1.2 heavy modular frames. So first I took a look at the default recipe. Default recipe is just inefficient in terms of all aspects. You require you require a lot more raw resources for every single thing. So this is out of question. So next I was left with this one or this one. So heavy flexible frame recipe or heavy encased frame. So both of these has its own advantages and disadvantages. One needs rubber, which is fine for me because I have lot of rubber in my factory that I am making. So that's not a big deal. But the other doesn't have rubber, but it just takes a lot more iron. I was taking a look at this, and one of the things that the reason I finally decided with the second one is it marginally uses a little bit less resources compared to this one, but that was not the main thing. The main thing was some of the numbers were really nice, and also that the second one didn't use rubber. So I don't have to plan on bringing rubber as another new raw resource for this, because I already need aluminum and nitrogen gas, which are raw resources that I need to bring. Now along with this, for the first recipe, heavy flexible frame, I need iron, rubber and limestone. So these are the three. For the second one, all I need is iron and limestone. That's all. So one less raw resource to bring means that one less item bridge that I need to build to bring stuff, all of that. So that will reduce a lot of effort. So I went ahead with the second recipe. Also the numbers were good, like 4 encased industrial beam. That's a good number versus this 3.6. 3.6 is again difficult to make. So finally I went ahead with this recipe, which is 1.2 heavy modular frames. Also this needs a lot less modular frames. Like for example, this needs 6 versus this needs 3.2. But I don't think there's much difference in 3.2 or 6 apart from raw resources, because you can make a lot of this modular frames using some of these. Like for example, the last recipe over there, you can make 5 of these per minute. So all I need to do is overclock it once, and I'll get probably like 6 modular frames. So that was not a big issue, but still, it's a minor thing. So at the end of the day, I went ahead with this recipe. I underclocked it to 1.2, and I just made that. So incorporating everything that I just said now, I finally built this blueprint. I made a big mistake when I first built it. So basically I had completely missed out on this bottom floor. Basically I started from ingots instead of ore, which was a big mistake, but I finally rectified it, and now everything is fixed. The most complex part of this entire blueprints is in the middle floor over here. There is a very, very, very complex balancing that I'm doing. It's perfect. It perfectly works and everything, but there are some things which are difficult to explain. So I have a little bit of simple explanation over here, but most importantly, let me just get rid of this designer. So clear blueprint, and then let me load this. So I was just working through this. So during my iteration process, I just was working on this first, the middle floor basically. And during that time, I was trying to see how much of the stuff can I fit in. And during that time, I made this. So let's see. So here, so this says iron ore, but that's not the case. This needs to get iron ingots. This is limestone though, so that's perfect. But here is the input for iron ingots. So iron ingot comes here, and then lots of balancing happens and it goes out. So And similarly, limestone comes here and everything happens over there. So let's start with limestone. I think that's easier. So 90 limestone comes in, which gets split into 3, 30, 30, and 30. So the first 30 goes here and makes 8.8 concrete. I don't need 30, I just need 26.4. So a little bit more, but that's fine. And the middle portion goes here and comes here. It makes 10 concrete. The right side goes here. It makes 10 concrete. So this one and this one, the output of both of these needs to be combined. So I'm taking the output over here, bringing it and combining it into this merger. And finally that becomes 20 limestone, which is what I need, which goes into the floor above. So that is perfect. So that's the 20 limestone that I need. So that's limestone. Now let's come to the iron. Oh my God, this is the most trickiest part. So I start with 235 iron ingots. Now here, so every single time that I have made balances, I have only used splitters and mergers to balance it. But this is the first time that I have incorporated belt speed into my balancing stuff. I really hate that. I don't like to use belt speeds to balance stuff because it's not scalable. You can't really upgrade belts and stuff, right? So you can't really do that. But in this one, I can still scale this part because I can upgrade these to Mark 6 or Mark 7 belt if it exists or anything like that. But I don't think they exist. I think Mark 5 is the last one. I'm not sure. But anyway, but it still has that option. Because the only belt that I have used for balancing is this one, which is a Mark 1 belt, which is extremely crucial, by the way. I'll explain that. But that's the balancing that's happening. Let's forget this balancing. Now let's just take a look at it. So 60 iron ingot comes here and it goes here into this. So this one, 60 iron ingots, I only need 57.6, which is fine. 60 is a bit more. I get 14.4 steel pipe. So this steel pipe directly goes into the most, it's like the final part. So let's just go here, go into this and make this 1.2. So this 14.4 steel pipe. So that's the final 14.4 steel pipe that is being made over there. This 8.8 concrete is being made over here. So this 20 concrete is being used for encased industrial beams. So this one and this one. But this 8.8 is going into heavy modular frames. This 14.4 steel pipe is also going into heavy modular frames. And these two are right side by side next to each other. So that's the 60 iron ore, which was the easier one. Now at the end of this one, this complex balancing, so here I think you'll get 75. So that 75 goes into, like, splits into multiple more splitters, and at the end, I'll just go to the end, by the way. So here it gets 20 iron ingots, which makes 13 iron plates, and over here it gets 6.5, which makes 26, and here it gets 45, which makes 11. It needs a little bit less. I'm giving it a little bit more than necessary, a little bit more than that's required for every single one of these, just so that, like, it works at 100% efficiency, and also it works well in terms of balancing. But yeah, that's what's actually happening. And so let's take a look at this first. Let me just change this. Yeah, it's this. Okay, so 235 iron ingot comes here. Now the way balancing works is, so there are two outputs from here, so 1 and 2. So if these two belts were same speed, what would happen is 235 would split into 2, which is 117.5, and it would just split equally. But because so 117.5, for example, will try to go onto the 60 belt, but it can't because it's a 60 belt. So what happens is only 60 goes in here and the rest goes there. So now what's happening is 175 goes into the left side belt, but only 60 goes into the right side belt. So you're effectively splitting not equally, but you're splitting based on speed, belt speeds. So you're getting 60 over here, which is constantly going here. So that's fixed. That's already done. So I was able to solve that. Now I'm left with 175. So this 175, I wanted to split it in different manners. So the first thing is, so if you see this right side part, this is going all the way over here to this, which is getting 100 actually. So this needs 96, but it's getting 100. 100 is becoming 24 steel pipes, which is also going up top. So this 175, I had to split it into 75, which is going there, and 100, which is going there, which is very weird. so 175, if you think of it, it's like 3:4 ratio. You need to split it in 3:4 ratio. So that's what this complex splitter is doing, or balancing. So what's happening is, so if we take a look at this, so that's the input. So input comes there, right? So let's just imagine this input is 175. So 175 comes here. So that's a merger. Let's just forget that. So 175 goes in there. So 175 goes in there, and if we see, so 175 splits into 1, 2, and 3. I think that should be yeah. Okay. So 175 splits into 3 parts. So each of these 3 parts is again splitting into 3 more parts. So technically I'm splitting 175 into 9 different parts instead of 7 different parts, because you need to split it into 7 different parts for 3:4 ratio, but I'm splitting it into 9 different parts. So this is splitting it into 3 more, this is splitting it into 3 more, this is splitting it into 3 more. And now what I'm doing is, out of those 9 different parts that I'm splitting, 2 of those parts that I'm splitting, I'm bringing it back into input. Basically, I'm merging it back. So now I have split it into 9 parts, but 2 of those that I have split, I brought it back into input, which effectively means I have split it into 7 different parts. Now that I have split it into 7 different parts, I just merged 3 of those into 1, and there is a connection over here in between. There is a belt which is going from this splitter to this one. So this one should effectively be going to another splitter, which will split it into 3 more, and that 3 along with the output from that will merge to form one singular one, which is basically merging 4. So instead of like splitting it into 3 and again merging all those 3 back, I just removed that splitter and I put everything as a merger. So basically this one single belt, you can effectively think of it as, it should effectively be splitting into 3 parts like this belt and again merging back. So this will equate to 3 different belts, and that will equate to 1. So this is 4. So this is the 4 part. So 3:4 ratio. So that's the complex balancing that's happening. So this is a very simplistic way of explaining it, like 3:4 ratio, how you can get it. This balancing is not complex if you think about it, but when you are building it, yes, it sort of feels a bit complicated, but it's not the case. It's straightforward in some cases. So this thing, I just compressed it because I needed space and everything. So I just made it as close to each other as possible, and I just made it work. There are belts which are going all the way throughout over here. By the way, every single one of these is connected. Wherever it needs to be, it is properly connected. So at the end of it here, I'm getting the 3:4 ratio that I need to split. So the 3 part is coming here, the 4 part is coming here. So 175, if you split it into 3:4, it's basically 75 and 100. So 100 is going there, 75 is coming here. Now again 75 is being split in some complex ratios. I think it's being split into 5 different parts. Out of those 5 different parts, 2 of the parts are being combined here, which is going from here all the way to here, which is again being split and merged to form some combination, and I'm getting 20. So the reason is 75 needs to be split to get 20 over here, and also it needs to be split to get 45 over here. So 20 and 45, so that's basically 65, and then this is getting 10, so that's 75. So this one is getting 20, this is getting 10, this is getting 45. So in order to make that, I had to split 75 into 5 parts. So 3 of those parts that I have split, which is basically 45, is going there, which is easy. 2 of those that are merged is basically 30. So that 30 is going there, is being split into 3, and 2 of those are being merged again, so that I get 20 and 10 separated. So out of this 30, I'm basically getting 20 at one end, 20 over there at one end and 10 over here at the other. So that's what's happening. So basically this middle 4 is basically just balancing stuff. There is nothing happening. It's just balancing, lots of balancing. And finally, I was able to achieve all the numbers that I want. There is very minimal wastage that's happening, which I really like. So whenever the numbers are like this, I'm fine with giving it one extra per minute, one ingot more, because it just ensures like it constantly runs at 100% efficiency, and it's fine. It's totally fine. So this is the middle 4, the most complex part of my blueprint. So now let me just clear that and load the final one. You just need to wait a couple of minutes so that everything loads. It is a very big blueprint. So let's just take a look at the bottom floor. So the bottommost floor over here is very simple. All it's doing is it's making iron ingots for the middle floor. It still has not loaded. Interesting. Okay, so it finally loaded. So here, for example, so this was the middle 4 which I explained. So here it was getting, how much was that? 170. It was getting 235 iron ingots previously, and 60 was being split over there, and 175 was going over there. So the same thing, it needs 235 iron ingots. So that 235 iron ingots is being made over here. So basically bring in iron ore, get split into appropriate smelters. Each of these is taking 30, which means that I'm bringing in 240. I can't really bring exactly 235. That's just not possible. It'll become extremely complex then. I'm not doing that. Instead, I'll bring just 240. That's totally fine. 5 more iron ore. And I'll get 240 iron ingots, which comes in here. And all the splitting, everything happens. I'll bring the limestone directly over here. Limestone doesn't need much. And all the balancing and everything happens. And from there, I'll bring everything up top. So here, all the outputs I'm bringing in up top. Some stuff over here which goes into encased industrial beams, and some stuff here which goes into reinforced iron plate, which then goes into modular frames, which then finally everything goes into this one singular manufacturer, which makes 1.2 heavy modular frames, and everything goes into this blender which makes 1 fused modular frames. So technically, if you think about it, in this entire blueprint, all I'm doing is heavy modular frames into fused modular frames. So technically, I'm only making heavy modular frames. All I have is one blender for this fused modular frames. Because aluminum casing and nitrogen, I'll just bring it from somewhere else. I have also angled it like this so that there's a lot of space over here, so that if need be, I can do some balancing for casings and nitrogen gas, but I don't think so. No matter what, I have some space here that I can work with. So which is nice. But yeah, pretty nice. So this 13 iron plates is going over here into this reinforced iron plate. So exactly 13. I need 12.96, which is fine. And then 26 screws also goes here, reinforced iron plate. Then this one needs steel pipes, like the 10 steel pipes, which is actually being made over here, which is the 45 iron ingot that it gets. So it's making 11 steel pipes. So that comes in here. It makes 3.2 modular frames, and then it goes there. So this one is actually pretty simple. It needs 24 steel pipes and 20 concrete. 20 concrete is what we got over here at the end of this over there. So that was easy. And then 20 concrete is this one, the 100 iron ingots, which we got initially. So that's making like 24 steel pipes. Is it making exactly 24? Yes, I have underclocked it, so it's making exactly 24. And then it'll get 24 steel pipes, which is 4 encased industrial beams, which is all perfect. So everything is perfectly balanced. So this is the blueprint. Man, it took a while to explain this, but I'm really happy. This was the most complex blueprint that turned out. I'm quite happy with how it turned out. I was really not expecting to use the most initial ore and get the final product. I really was not expecting it. I thought I wouldn't have enough space, but I was able to make it, just barely make it, by the way. Even a single tile above, I couldn't fit the blender. Also, this is another thing. I did not think Blender was taller than a manufacturer. Manufacturer definitely needs more space, but I really thought Blender was smaller than the manufacturer, but that's not the case. Now that I'm looking at it, it's a lot bigger than manufacturer. So I'm quite happy about this. So yeah, a simple design at the end of the day, and I was able to put everything together and make the final factory. So my factory has grown even more. Man, I really love this design. Like this part, this factory over here, it's becoming even more and more and more hectic. I really like it. So I built the blueprint over here. So this is the exact blueprint. I haven't changed even a single part. So I brought the iron ore, bought the limestone. Okay, this is missing this. Yes. Okay. So iron ore is coming there, limestone is coming here. Everything is perfectly being split and then converted into its actual products. Look at this. Fused modular frames. Fancy stuff. We are slowly making complex cube structures. So yeah, pretty nice. So yeah, so this is making fused modular frames, and it's working at 100% efficiency. I like to see that 100% efficiency everywhere. Yes, nice. I have already checked all the smelters and everything. Every single one of these is working at 100% efficiency, which just proves that all the balancing and everything is working properly. So yeah, so fused modular frame factory complete. There is nothing more left apart from just unlocking next milestones and moving on to future projects. Basically, I have some projects in mind, some power stuff, some weapons factory, and then the space elevator stuff. So once I complete all of that, that's when we'll be moving on to tier 9. So we still have quite some stuff to do, which I'm looking forward towards. So yeah, so those will be our future projects. But yeah, this is really nice. I'm really happy how this turned out. This also adds a lot more stuff to my base over here. Lots of complex things happening. And in the middle of that, there are also some miners, which looks cool. And each of these designs has its own, like, it's a lot different. Every single one of these is different. Like even in terms of blueprint, like some of these have some concrete pillars, some of these is just steel pillars. There are some completely glass floors, there are some mixed floors, there are some gaps here and there, like there are belts running everywhere. I really like this. This is really chaotic and I like this. The fact that if there is something wrong and I myself can't figure out what's happening is pretty exciting. But at the end of the day, I don't think anything is wrong. Everything is perfectly balanced, so I'm fine. So yeah, so that's my used modular frame factory. So with that, I'll be ending now. So thank you everyone. See you guys in the next video. Bye.